Okay, we're recording this part for Evan. Everybody say hi to Evan.
Hi.
We miss you. Okay, hope you feel better. All right, let's start with 38 and 39. Okay, so what do you notice about those of you who had success with 38 and 39? What was your thinking? What was your methodology? Okay, well,
You just find like the nearest number that's divisible by 4 and then go from
so
there.
why 4? Okay, so you're talking about
4 trig function derivatives and then they keep cycling.
okay, so it has to do with like a cycle, right?
Yeah.
So if y is sine, and then we find y prime, what was that? Cos. Okay, and then y double prime, negative sine. Sorry, I should have my x's. Okay, and then y triple prime,
Negative cosine.
negative cosine, and then y, the fourth derivative,
Sine.
it's back to sine again. And so the cycle repeats itself. So it's almost like I can kind of, so this would also be equal to y4. And if that's equal to y4, then this one would be equal to y5, the fifth derivative. And this one would be y6, and that one would be equal to y7. And then by that time I get to y8, and I wrap back around again, and this is now y8, the 8th prime. Okay, so it's all in the patterns or how many derivatives there are. So if we are being asked in 37 and 38 to find the 999th derivative, you just have to figure out where 999 would fall relative to cycles of 4. It's basically how many times does 4 go into 999, and then what do you have to know besides how many times it goes in?
How much is left?
What the remainder is. Okay, that's called modular math. Okay, it's the difference between, like, modular math is like military time versus regular time. You know, military time would be 15, but regular time we say 2. That's because that's modular 12. So 15 has a full cycle of 12 plus 3 extra. And so this would be the same thing. If you're trying to find out what is, the 999th. Okay, well, I believe that 4 goes into that because 4 goes into 996. And so this would be the same as the third derivative because it's 3 past 996, which would be the full cycle of 4. So you do 38 and 39 the same way. Does that make sense to people who are asking about that?
Is there like a specific way to solve that, or do you just
No.
do it that way?
Yep, that is. It's sort of a logic reasoning kind of thing.
Long division. I was like, wait.
Yeah, long division, 999 divided by 4. Let's see, that's 2, 8 minus, carry, okay, okay. All right, so then that's, that's 4, and then 16, and then, okay, yeah, so that's 39, so that would be, 9, 36, so the remainder is,
3. And then that was what I was
and then that would be the same, yeah, same thing, okay. All right, so 38 and 39 are the same. Okay, 7 and 8. 7 and 8 are both quotient rule problems, followed by some basic arithmetic with a little trig. All right, so 7. It was 4 divided by the cosine of x. And so that's going to be a quotient rule problem to find the derivative. So my y prime then is going to start with the cosine of x times the derivative of 4, which is 0. Okay? Ethan, find that on yours. That was your spot. Okay? And then 4 times the derivative of cosine, which is negative sine x. All right? Over the cosine of x, which is quantity squared. All right, so my 0 knocks that out. And then I'm left with 2 negatives. So positive 4 sine of x, and then cosine x multiplied by cosine x. Okay? All right, and so then if you think of this, the rules of multiplication say it's 4. And then I can take sine of x with the denominator of cosine of x. And then I don't have anything left, and I have another cosine of x. It's all multiplication. This is not addition, this is multiplication. So the cosine squared means cosine times cosine. So if you think of it that way, then you can see more clearly how they got their answer in the back, right? So they would have 4, and then this term here, that's tangent, And then this term here is secant. And so you can see it a little bit easier if you just think, oh, this is not the same as common denominators. All right, this is multiplication and you're splitting up the denominators separately. Yeah.
So you know how they say like any equivalent answer would be
Mhm.
technically correct?
Yeah.
Could you leave it at
Okay, any
Or
equivalent
sign.
answer. All right, so yes, if this was a free response question and you stopped right here or something like that, okay, totally, you get full credit for it. This is most likely going to be a multiple choice question. So you have to find the answer that matches. So you might have to go farther in yours to get it to match the right one. That's often what they'll do with these types. Okay? Yeah.
Anything equivalent, could you like leave it like the first stage, like don't supply anything?
You like zeros and stuff, they're not gonna want, yeah, they're gonna want you to at least multiply the zero out. Yeah, clean it up a little bit. Okay, so 10 is gonna be similar. It's gonna be a quotient rule again. So this time we're looking at a numerator, that's the cosine of x, and then the denominator is 1 plus the sine of x. All right, so if we take the derivative of that, you're gonna start with 1 plus sine of x, and then times the derivative of cosine, which is negative sine, and then minus, let me extend this a little bit further. Okay, then we have the cosine of x, and then times the derivative, which is 0 plus cosine of x. And then you're going to want to clean that up. Okay, so this takes some distributing. So I would say you want to think of distributing your negative sign, but also distributing your cosine. Okay, the 0 isn't essential there, so if you had already like eliminated the 0, that's okay. But we end up with negative sine of x. Some of you lost it right there. You missed your negative sine of x, I noticed on your homework. Okay, then minus sine squared of x, because as I distribute. And then the first cosine when I distribute is 0, but then I'll have minus cosine squared of x. Okay, and then 1 plus sine of x squared. Okay, so here's where it comes into, we sort of have what we call like partial factoring. You notice that these terms here have a negative in common and they have a square in common. And so I'm not going to be able, well, I guess I could pull a negative out of the whole thing. Why don't I do that? Okay, if I pull a negative out of the entire equation, I have a minus, a minus, a minus. So if I pull a negative out, that'll leave me with a positive sine of x. It'll leave me with a positive sine squared of x and a positive cos squared of x. And the reason that that's helpful to me is because now I have sine squared plus cosine squared, which is always going to be equal to 1. All right, so then I see, oh, this is positive sine squared plus cosine squared, so that'll be equal to 1. So I'll have negative 1 on the outside. I'll have sine of x plus 1 in the parentheses, and then I have 1 plus the sine of x. The quantity of that is squared. And that's reducible because sine plus 1 and 1 plus sine are the same thing. In addition, the order doesn't matter. So I can reduce one of those with the power, which leaves me with negative 1 as my numerator and 1 plus the sine of x as my denominator. So that was number 10. Okay, looks like the last thing was maybe number 24. Oh no, 34 and 33 and 34C. Okay, so 24. 24 was the Newton's definition. How many of you wanted to see that? Somebody asked it.
Okay.
Okay, that was yours? Okay, anybody else need to see that? Okay, let's work on that separately because that'll just take a little bit. But were you able to watch the video on the sine one and understand that all the way through? Mostly?
Yes,
Okay.
I was having a bit of trouble, and then let her see with the explanation. I was definitely
Okay.
confused.
Okay, but that's, are you talking 34, 33 and 34? Or are you talking 24? Because 24 doesn't have letter C.
Oh, then 33 and 34. Yep.
Okay, we're talking 33 and 34. Okay, I really feel like when you get to a describe the motion equation, I really feel like there's some key parts of motion that you want to find first. All right, so the elements of motion, when you think about that, okay? You want to find out when it's actually not moving. Okay, it's kind of a oxymoron there. It's the antithesis. If they want you to describe motion, figure out when it's stopped first, okay? Then you'll have intervals between those times where it's stopped that you'll be able to decide is it moving to the right or to the left or to up or down or on those, okay? So find that first and then set up your intervals between each of the rest periods. Okay, between those points where it's going to be at rest. So let's start with finding when this thing is at rest. Okay, how do I find when something's at rest?
And velocity 0.
Set the velocity equal to 0. All right, so let's start there. At rest. We're going to take our velocity equation, which
-2
for 33, okay, should be -2 cosine t. Set that equal to 0. And so it's going to be at rest every time the cosine graph is equal to 0. And that happens multiple times. Okay, when's the first time that the an object would be at rest if that's its velocity equation?
pi/2.
Okay, pi over 2 is the first time. Okay, when's the next time it'll be at rest? 3 pi over 2. And then 5 pi over 2. All odd intervals, 7 pi over 2, okay, etc. All right, so finding out when it's not moving is helpful. Now I want to know what is it doing between each of those times at rest, okay? So this is what I do when I'm setting up my intervals. Time is going to start at 0 in this problem, okay? Time always starts at 0, so I want to find out my intervals are the time between 0 and pi halves. It has to be doing something. And then it's going to be at rest. And then it's going to be between pi halves and 3 pi halves. And then it's going to be at rest again. And then it's going to do something else between 3 pi halves and 5 pi halves. And then it'll be at rest. And then we just have this same ongoing pattern over and over and over again. So now I want to know, is it going to move to the right? Or, let's see, simple harmonic motion, does it tell me if I'm going right or left or up or down? Okay, positive or negative, let's just say. Okay, so I want to know what direction it's going. So we've done this now, we've established our intervals. Okay, now you want to determine the direction using velocity, because velocity is a vector. And velocity will always tell you what direction you're going. So check the velocity in the interval. Pick a random time within this period. Okay, give me a sample time value that's between 0 and pi halves. Pi over 4. Check the velocity at pi over 4. Okay, so check v of pi over 4. Okay, what is it? I don't care what its value is. I just want to know, is it a positive number or a negative number? All right, well, let's go back to what our velocity was. Our velocity is -2 cosine t. If I put pi over 4 into there, the cosine of pi over 4 is a positive number, but multiplying it by -2 will give me a negative number. So it is a negative value. So that tells me the motion is negative in that interval. Okay, so negative motion would either be moving to the left if I was on a horizontal plane, or moving down if I was a vertical plane, like a spring or something going up and down. So I have negative motion. So as you're saying the particle will have negative motion between 0 and pi halves. Okay, move to the next one. Just pick a random value that's somewhere in that interval. What's the most obvious one to check? Pi over 2 is I already at rest, so I can't check pi over 2. 1 pi. Okay, so check pi. Okay, figure out what it is. So go back. Well, my velocity is -2 cos t. If I put pi in there, that's going to be cosine of pi is -1. Multiplied by the -2, that's going to be a positive value. So that means in that entire interval, I'll have positive motion. And then you check in the next one. And harmonic means that it's just going to keep flip-flopping back and forth all the time. So the next one will have negative motion, and the next one will have positive motion. That's what harmonic means. It just goes, it's oscillating back and forth.
Would you ever have an oscillating graph that, like, positive, stop, and then goes back to positive?
With absolute values, you would. Okay, and that would be like something like a basketball that was bouncing, you know? So it'll have like bounce, 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 right? So then it's not crossing under like a, okay, so its oscillation doesn't go down to the negative part, yeah. Where it hits a hard stop of rest and then bounces back up again.
Would we
Okay.
be allowed to use our calculators and things like that? Because in the book it said we could, but would we have to know no calculators?
Both. I would say this could be either or. Yeah, you should be able to, I mean, these are, -2 cos t is a pretty easy equation for you to just pick some trig numbers and plug it in. Now, if you've got this big cubic or this big, you know, log or whatever, you know, then yeah, you're gonna have your calculator to start checking those numbers. But sometimes I feel like, okay, that's a good, that'll work for every, no matter if our motion is trig motion or any of the other motions we're gonna learn, which we haven't learned those derivatives yet, but we will in the next chapter. But this strategy of, okay, if I'm talking about motion, always find the at-rest places first, because then you're setting it equal to 0, set up some intervals, and then test numbers within that interval, because within that interval, the behavior will be consistent. The motion will be consistent within that interval. Ethan, you had a question?
Okay, the book had like a lot more specific like writing than I did. It says like goes back and forth between like 0 and 2, and like could we just say like it goes right and left like this?
Yeah, between, you know, you would want to specify the time interval.
Yeah.
So in this time interval, it has positive motion because the velocity was positive. And this time interval has negative motion. This problem didn't specify if we were moving, like I said, horizontally or vertically. If you are told, then you should use, like, positive motion would mean to the right, or positive motion would mean up. So you'd want to use those words if you knew. Yeah.
Will it specify how many intervals we should use to determine its motion?
Usually you get like a closed interval and as opposed to an open one here, but you can definitely tell what the pattern is going to be. That, you know, this pattern here is, so I could predict that the next one is going to go from 5 pi halves to 7 pi halves, and then it's going to be at rest again. And then I could predict the next one's going to go from 7 pi halves to what would be the next stopping point? 9 pi halves. And what would happen in that interval? What direction, what kind of motion would I have? Negative, okay? So you could, but usually you'll get a closed interval so that you only have to go a certain amount. Okay, anybody else?
Just a
Yeah.
quick question on that. So when describing that, you could just say positive in this interval and negative in this interval
Mhm.
rather than like giving a value for like the height.
Sure, yeah. You know, if they want to know how high did it go, okay, when it's at rest at pi halves, could you figure out how high it went? Sure, you take your pi halves and you put it back into the position equation, okay? Because pi halves has 0 velocity, but it's going to have a position that's not 0. Its position will either be, you know, the bottom or the top when it's at rest.
And then when it says describe it, like what aspects is it looking for? Because like I know in the book it had like a bunch of different things that you could use to describe it. So like what do you need to like?
Yeah, it'll be a little more specific, okay? So, but you want the time interval,
Okay.
and you want the direction for sure. And then usually there'll be a specific follow-up question with maybe give its position. Okay, you can really only tell position at moments of rest right now. We'll be able to do more of position later. Okay, let's finish up trig then. Okay, we have 4 trig derivatives to do today, but you'll be glad to know they don't require Newton at all. Okay, so you can go grab your B, your 2.5B.